Good morning. My name's Colm. I'm a principal engineer at Amazon Web Services. And I've worked at AWS about 12 years. My first day I was working on CloudFront, helped build that, and Amazon Route 53 after that, and some other services. But for far longer, I think for close on 20 years now, I've also been an open source developer. Was one of the lead contributors for the Apache web server, Apache HTTPD. Helped write a good chunk of the Apache web server 2.0 and the Apache portable runtime, which is just kind of a sub-part of that project, and some other open source projects. Things are out there. A lot of stuff that's in the Apache Foundation because I'm a member. And what I'm going to talk about today is how we manage, and it's a big we, how like open source projects I'm a part of manage security, how we try to prioritize security, and how we handle security issues. And I think that's useful to hear about, both if you work on open source, because maybe there's things in our practices that are worth copying, but also if you just consume open source. I think it's really worth knowing how this stuff works so that whenever there's like a CV reported or any kind of security issue, you kind of have a sense of what the flow is on the other side, what's happening behind the scenes to make those changes ready, to have fixes available. And then, we all consume them and we integrate them into our applications and so on. So written on my office wall, this is actually my old office, I've got four things that we like to think about whenever we're designing systems, right? Whenever we are, whenever we have to, make trade-offs in our designs. I can make something fast, or I can make something highly available. The way I resolve those dilemmas is by going to this set of like trade-off priorities. It's kind of written in stone. It's never changed the entire time I've been working here. And right at the top is security. Right, our top priority is security. And the way I know that, like for sure, is if we had some kind of theoretical security issue, right, that meant, say, like a customer's data was at risk, like immediately, and was actively being exploited, and bad things were happening, right? We would probably turn that system off, right? We would sacrifice availability if it really, really came to it, because security really, really is that important. And the same for all of these other things. And that's obviously true at AWS, but I think these priorities are also true for every open source project I've ever been a part of. On the Apache projects that I've been, way before I joined, the Apache Software Foundation and the folks who were there in the very early days and set everything up, I had a really strong focus on security in terms of, there's security aliases and security policies and security lists and whole mechanisms for handling any issues that are reported and making sure that they're fixed correctly. And I've seen issues reported, and like the folks involved, even though we're volunteers, a lot of us just working in our spare time, to make the magic happen, still will like drop everything and prioritize handling that issue, which is really, really cool. And that's what I'm going to talk about. And there's no free lunch with this stuff, right? Like we didn't get to that state through accident. I've seen other open source communities and other open source projects not succeed over time because they kind of treated security like an afterthought, or as something that, kind of a nuisance. Why do I have to deal with this? And there's a certain kind of fairness to that, right? If it's purely a voluntary work and it's a complete kind of side project, and people are purely doing it in their spare time, and they're not committed to it as like something they want a lot of people to be using on a regular basis, I can kind of understand that. But thankfully, that's very much the exception. Most open source projects, people are contributing to them and building them for that sense of, either because they're being paid to, right? There's a lot of professional open source development these days, or even when they're volunteers, they still take a lot of pride in that work, right? And they want to be able to stand over it, and they know that their reputation is on the line. And we're going to talk about how we achieve that. Like how is it that we actually promote security as part of an open source project? How do we embed that as a core thing that even the newest contributors know to pay attention to? How do we codify and kind of write some of that down? Like what do open source security policies look like? And then we're going to talk about how issues are handled, right? So if somebody finds an issue in open source software, what that workflow is like, how we do that in our Amazon open source software. I do that, so that's fun. And then I'm going to talk a little bit about how to take all that and then use it to assess, the security of open source projects, right? Especially if you're evaluating, I want to use this open source library or application. It's probably good diligence to, check that they actually stay on top of security issues and are able to handle those. So we'll start with promoting security and how to do that. I start by literally using, propaganda on my wall, right? I have, and not just propaganda on my wall, but, I've put it in my email signature. I have put stickers on my laptop. Every open source conference or convention I've gone to, I've made sure that we had sessions and time and birds of a feather sessions to just talk about security, right? To really make it clear that this is just a really important topic to us. This is something we get excited about thinking a lot about, and just even whether it's a fun brainstorming session around, what can we do over the next year in our development life cycle to add some cool new security to something like Apache. I remember really exciting meetings like that at various Apache cons. If a project's big enough, we might have dedicated aliases to just talking about security. How can we improve this? How can we do this? Back when we were developing mod SSL for Apache, we put a lot of work, and it took a lot of brainstorming and documents going back and forth into exactly how things like mutual auth certificates or client certificates would be implemented, like how people would be able to specify, who should get in, who should not get in. And, I did that long before I joined AWS. And I was kind of surprised, when I then joined AWS, where we do this kind of work, very professionally, it's what we're all paid to do. It was pretty much the same process, going through a security review at AWS felt like that, with all these folks just thinking really hard about the feature and what it should look like and how it should be secure and how we would make sure that, users wouldn't cut themselves on sharp edges and so on. And it amazed me that this, ad hoc group of people who had gotten together to write the Apache web server had, a very similar rigorous process. Long before that, it's really cool. For projects that do prioritize security, the one kind of big difference that I see in how they evolve, how they kind of manage their feature pipeline, is that the most common question customers have and the most common question users have is when am I getting a new feature, right? And we are typically pretty cautious about that about answering that, especially on the open source side, because we know that, well, we're not going to release it until we're sure, right? We're not going to release it until we're really confident that it's right, if it's a security critical feature. But that's not an obvious thing to do. Sometimes some projects are everything's experimental, everything's a beta, let's just get it out there and see what happens. But there's a difference between that and other projects where no, let's make sure it's really safe and secure by default before we put it out there, before anybody can cut themselves on it. And just setting that tone as part of the open source project really, really matters. And that's something you can look for, right? That's something that's pretty easy to to spot in a project. It like what it really means for security to really be priority one is it's pretty much the same for an open source project as it is like in my day job at AWS. You know, when I'm thinking through it as a lead developer or a PMC member, I'm always asking, like, how are we promoting and rewarding security in our development culture, right? And that can be as simple as, like, if somebody really finds a good catch in a code review, you know, if they notice, like, hey, this mistake on line 17, you know, would have been a security issue, like, we really celebrate that, you know? Like, I've seen people make those, you know, nice little finds, and like a just total pile-on of like 10, 20 more people then replying going, wow, nice find, that's cool, right? And like more than the average, you know, nice find. Like really celebrating and rewarding those kinds of things. And watching as the project, you know, really tries to integrate security as a first-class thing. You know, there's projects, we'll mention some later, that have really done a good job of that, where they really hold like security as one of their landmark features. It's all example of a saying I like to use, which is, you know, there's no recipe for any of this really. It's all a matter of like team culture, right? And if we don't have a healthy team culture that reinforces and rewards all this stuff, you know, we're just never going to be in the right place that we need to be. All right, 1 second. I gotta find my place. So this all starts at the top. I gave a talk yesterday, which is kind of the complement to this talk about how we do and prioritize security at AWS. And I said, you know, at AWS, this culture setting really does start at the top. You know, all the way up to our CEO and our Chief Information Security Officer, who know about security issues. They really care about them. You know, they want to know whenever anything is reported. They want to, you know, make sure that we stay on top of it. There's no way to avoid that. And you notice that in the, you know, open source projects that have lasted like long, you know, tenured periods of time, where large numbers of users are able to trust them and use them, they have leaders like that. You know, whether it was just in their core DNA, part of the folks who founded them, or folks who joined a bit later as the project grew, like they just have like effectively security sponsors, you know, folks who are just really passionate about this topic and are just infusing it into the entire development team. And it's like there's just, that's not optional. There's not, if you know, projects that don't have that tend to just accrete security issues. And you know, I'm really happy that projects I've been a part of, you know, I hope I've done a pretty good job at that. You know, I learned a lot from working with, you know, mentors of mine and, you know, more senior folks at the Apache Software Foundation who really showed me like what handling security issues means. Like I don't think I'd be anywhere near able to do it today if I didn't have all that experience. It's a great way to learn too, to pick up all that experience. The other thing you tend to see, right, in projects that value security, is that they also value just like clear, readable code, right? I said this yesterday too about our code at AWS, but you know, I've seen projects where the code almost reads like a poem. You know, it's really easy to follow, and it's just very clear what's going on. It's been really well constructed and structured, so that it is easy to follow, and it's not really hard to do code reviews and so on. And almost invariably, you know, I've seen the niggliest, hardest security issues only crop up in the hardest to read parts of our code bases, you know, in the kind of, you know, harder corners of open source projects. You know, classic example of that is the Heartbleed vulnerability in OpenSSL, which, you know, a lot of OpenSSL is really well written. It's actually pretty well designed, but it had some corners that were really hard to follow, and then inevitably, you know, that's where an issue could crop up, which is not what you want. But just asserting as part of the culture, right? We want our code to be clear. We want it to be readable. It's absolutely invaluable. A good sign of this, by the way, I'm not one generally for like a lot of bureaucratic rules around code style. I tend to try to just use code formatting tools rather than having to like write in a particular style, just because I'm part of so many different projects and they each have different styles. But one thing I'm a really big fan of, and I think is a good sign, is that when you see a project like turning on the most like pedantic and extreme levels of warnings in their builds, that's usually a really good sign. That means they're really trying to eliminate any undefined behavior. They're trying to really scrutinize things. If the project goes even further and starts to do things like static analysis, that's like A+ gold star. But almost invariably, the projects that really, really value this stuff have gone to the trouble of enabling this stuff. And that tells you a bit about their motivations, right? When you're maybe less experienced, or maybe you're just of that nature, a lot of folks just want to write some code, get it working, ship it, and you get that little satisfaction buzz of like, well, you built this thing and it worked and it did something. But the more mature, experienced folks realize that might come back to haunt you. You probably need to write a bunch of tests, and you probably need to turn on all these things that detect likely errors. Another thing you tend to see is that the projects really care about having defense in depth. Whenever there's a security issue, they don't just try to fix the bug. They think cohesively around how do we prevent more issues of that kind, right? A good example here is memory safety, right? So if you look at the internal design of something like the Apache web server, which I'm very familiar with, or OpenSSH or OpenBSD, they have done a lot of work to make sure that their core libraries and the ways of accessing memory have just built-in safety, right? That it's hard to do buffer overflows, and they use all sorts of cool techniques like guard pages and special allocators and all kinds of things. And I don't want to go into those details, but the point to take away is that they've really thought about it. They've got this humility, right? That they realize, oh, we're going to make coding mistakes because we're humans, and humans make coding mistakes. Coding is hard. It's not something you're just perfect at out the gate. And they have, built-in parachutes and safety nets that make sure that when that happens, it's not going to be completely fatal, right? And over and over again, the projects that have these defenses in depth, get saved by them, and it's really cool, and that's definitely something I look for. The next sign of this kind of like, hey, we've got a really strong security culture, and we're integrating it, is that they go to the trouble of actually having a security policy, right? Some projects don't, but I think these are really important and really critical for success. We have one for all of our open source projects, and it's the value of having a policy is, security issues when they're reported, especially, that can be an urgent or stressful thing, right? And it can be also an intimidating thing. If a security researcher or a vulnerability researcher comes along and says, hey, I found this issue in your code and it's exploitable, it's really, really valuable to have spent time in advance thinking about and writing down, how we're going to handle that, so that we're not just winging it and making it up as we go along, because it's harder than it looks. I think there's some really good examples of these. OpenSSL, a project I already mentioned, they've got a pretty good one. You can just go read it. But they take the time to write down, here's how to report issues, here's how we triage them, here's how we classify them. And they tell you up front, right? Which solves a lot of arguments that could happen further down the road before they occur. It's really, really cool. And the ASF, the Apache Software Foundation, we have one too. The most critical things on these is, there's a really clear, can't miss it place to actually report security issues. I always when I'm setting these up, I always like to make sure that if I do a search for like, my project space security, that will land on this page. And if it doesn't, I'll try to rewrite it and put enough terms in there to make sure that it does. But there's typically like, here's an email address to send a report to. Here's maybe a PGP key if you want to encrypt it and keep it super secret and send it to us. And here's some guidelines about what we're going to do on the other end. Promise to keep confidentiality and so on. OpenBSD has another one. These each have these are really mature ones. I think each of these policies is probably close to 20 years old. So there's a lot of lessons in there. They've been refined over time. They're well worth reading. But you'll notice if you do read them, and if you read more, that projects aren't completely consistent around how they rate or categorize issues. And that's in large part due to just each project operates in a slightly different space and has slightly different risks and different users and profiles and so on. So we've done the same. We try on our side for issue handling. We try to keep things relatively simple, to have a pretty simple kind of form of categorization as possible. The ones we use for open source projects like Amazon S2N, so that's our implementation of SSL and TLS, obviously a very security critical application. We in our policies and in our written down documents about how we handle issues, we just have 3 classes of severity. We really haven't found a need to go beyond that anymore. But they're similar in spirit to other folks. Thankfully, we don't get many issue reports. But if something is reported, we like to say, well, is it at all practical? Is this a very marginal issue that really it would take a lot of crazy circumstances to be exploited? Is it a kind of low grade, like resource utilization? Like, is it that the attacker can basically just waste some CPU at a low level or something like that, but they can't like access data they shouldn't or anything like that? Those we call low severity, right? That's pretty easy to be comfortable around. And the point of that categorization is, well, if it's low severity, that means we can give ourselves a little bit of time to respond to that correctly, make sure we're doing all the right kinds of testing and so on, and we can probably use our normal deployment process as part of that testing and so on. We don't have to do anything extra special. For medium severity stuff, thankfully we've never had any of these. Is things like, well, there might be memory disclosure, like someone can access memory they shouldn't be, but like they have to be on the same box. It's not like they can do it remotely, or they can crash the process. But typically processes restart. So again, that's kind of medium severity. And those now we're into the territory of like, okay, well, if we ever get one of those, that is kind of like, okay, we need like an immediate response and team huddle, and we're going to start thinking about those. All the way up to high severity, where we're talking about hopefully things that would never happen. Like remote execution is probably the most severe kind of vulnerability that could possibly exist, right? Somebody can literally log in, right? And so writing these down and just having them around is kind of the beginning of our process for how we work with security researchers and people who find bugs and report vulnerabilities. There's like a common mistake people make about this, which is that you're building a project and you take a lot of pride in it. You've shipped this thing, a lot of users are using it, it's really, really cool. And then somebody comes along and reports a bug in it. There's like a natural tendency in human nature to kind of treat that person as an adversary, right? To kind of think, okay, they're criticizing my work, they're finding flaws in my work, and on top of that, they're probably going to embarrass me. They're probably going to take this work, this find that they have, and publish it, and that's going to make me look like an idiot. This is what's playing in people's heads. And it just naturally sets up an adversarial relationship, right? And even if it's not like completely explicit, it can often still be there emotionally. But of course, like that's just not the right worldview at all. In reality, developers and security researchers are on the same side. They're collaborators, and the adversary is attackers or people who might try to exploit issues. And we're all just trying to protect customers and users at the end of the day and make sure that nobody can do that, right? But it is really hard to really fully internalize that, because just that, the emotion runs so deep, and the natural stress of somebody coming along and reporting a flaw in something you've done is just so intrinsic to human nature that, it takes a lot to build up that internal sense of like, no, we really are all on the same side. We're working together. We're basically one team, all trying to fight this thing. And that is something that, again, the more mature, tenured folks can really help lead and tone set. It makes a really big difference having that mentality and letting it spread out. So when we handle a security issue on our open source projects, it's a little different than how we handle security issues on, say, an Amazon Web Service that's running. And it's a little different because the open source projects are maintained in public, right? And we sometimes have, folks working on those projects who don't work at AWS, don't work at Amazon, but they deserve a say. They're part of that project, right? And so, we need to find ways where we can handle an issue sensitively and confidentially and make sure that we're not just, increasing the risk that the world is exposed to, but also, adhering to our open source principles of like, hey, we want everybody to have a say, we want everybody to have a meaningful say, and not just find out about things after the fact. So it's a little bit different. But I'm gonna go through the workflow. So I lead this process for a bunch of our projects. So I'm literally just gonna go through all the steps of what I do and what's in our head as we do it. But the zero step before anything is ever reported, you obviously have to have somewhere the researchers can report this to. This is the absolute minimum bar, right? They just need to know somewhere to actually send it to. In reality, if you've been around a while, if you've worked with researchers before, you'll just maybe have organic connections with those folks. You've been to the same conferences, you've had beers a few times or whatever, and they might just know to reach out to you and contact. But if you don't have that kind of network, it's really critical to at least publish a page that's like, well, here's how to report. And obviously you can't guarantee someone who finds an issue is in your network. So I guess you always need to have this page. So the first thing I do when we get a report in is to acknowledge the report, say, hey, we got it. Make sure they know their email didn't go to a black hole. And then something I think is really important and underemphasized is, if the issue looks remotely credible, I thank and congratulate the reporters. As the very first thing I do, right? For a few reasons, because one, I think it really helps tone set and establish that we're all on the same side. I'm not one of those crazy projects who's going to treat you like an adversary or, try to make you go away or sweep things under the rug. Establish really early on, start earning some goodwill, because we may not know each other yet. And then the congratulations matters, especially if they're in academia. Often if folks are working on security issues as a research topic, and maybe they're going to publish it eventually as part of a thesis or whatever, finding these issues can be really big milestones in their career. Even the best researchers find a small number of these in a given year. It's a really big deal, and they kind of deserve to be congratulated. And if it's real and it's there, they're the first person to notice it. It's a really cool thing. At this really early stage, we don't know how long it's going to take to fix. We don't know what's going to be involved. So just say, look, we'll get back to you usually within 24 hours with some next steps. And once we've had a little kind of chance to analyze things preliminarily, preliminarily, and we'll get right back to you. But we try to make that a pretty short window. So after that, behind the scenes, then, so not behind the scenes, sorry, as the kind of next step with the researchers, we'll be like, okay, we have essentially like a core set of contributors, right? Who are folks who are tenured, they've been on the project a while, we all trust each other, both in our judgment, in our technical judgment, and also in our ability to just keep things confidential, right? And that core security group at this point is like disclosed on this issue, right? We tell this set of folks. And so this is like, maybe 3 or 4 core contributors to the open source project. They may all work at Amazon, 1 or 2 may not, depending on the nature of the project and how collaborative it is. And we'll tell them and we'll get them to have a meeting with the security issue reporter or the finder, right? And what we'll do is with the researchers and with the core contributors, we want to talk through the report in unbelievably tedious detail. And we want to confirm with everybody involved, look, we all have a full understanding of this issue, right? Like this is exactly the circumstances it takes for it to occur. And like, here's the exact consequences of that issue, right? And it can be very easy for there to be ambiguity there. So it's worth having a very, very tedious conversation. Sometimes researchers, researchers are used to having, companies and open source projects come back to them and say, well, that's not as serious as you think it is because of X, Y, Z, right? And researchers can often interpret that as in bad faith, that they're just trying to minimize how serious an issue it is. And security researchers often also have the mindset, and it's a good one, that well, this is how bad we know it is today, but it might be worse, and we should always assume the worst, right? And like that's what we should work on. And so this conversation can be a little delicate because you want to make sure that nobody misinterprets this tediousness as an attempt to like minimize the thing or down talk it or anything like that. So like you have to set that context a lot along the way. So once we fully understand what triggers the issue, what the consequences are, then we can talk through, okay, well, what mitigations already exist? Are there things in the software, flags that can be enabled, modes that can be used, options that we can trigger that somehow mitigate this? Like, are there, or is it going to have to be a software change? Are there configuration changes an operator or administrator could make? And that's for 2 reasons. One is like thinking ahead to eventually how you're going to publicize this issue and tell people how to handle it. It's nice to be able to tell people, well, you don't have to upgrade your software. You can just change this setting and you're good. Or to tell people, but the other reason is to also measure what the impact might be. And if it can be mitigated by a setting, then really maybe only the people who don't have that setting already are at risk, right? And that's very valuable to know, very, very helpful when later we need to go out and make sure that everybody gets upgraded to a secure posture. Then we start actually talking through a fix, and for a lot of issues this is often simple, right? Sometimes security issues are one line, right? And it's a very quick conversation with the researcher. Yeah, obviously we need to just change that line. Yeah, we're all good. And sometimes it's more complicated. Sometimes they're very intricate or subtle or nuanced issues, and talking through how we're going to mitigate it can require a lot of nuance and detail itself, right? But we want to talk through all that so that everybody's on the same page about how much work we're talking about doing, right? And that's really helpful for the next step, which is to then agree on a timeline, right? For like, how are we going to, how long are we going to take to fix this thing? If you've done a good job in the previous step of talking through how complicated the fix is going to be, then it's pretty easy to have this next step. It's pretty obvious that like, really low-level, broad impact issues, like for example, Spectre and Meltdown, which required changes in many operating systems, many libraries. Took, that process, that timeline was months, from discovery to complete fixes. And you can understand why. It's a very complex, very hard to mitigate, interesting space, right? Whereas if a one-line change comes in, if a one-line issue comes in, it's kind of unreasonable to say, yeah, we're going to take 3 months to fix that. That's not credible. But you agree on the timeline. We generally shoot. We generally shoot for. We don't want to sit on issues. We don't want them languishing. There's always a risk somebody else might discover it. So we want to get it out there as quickly as possible. And it's generally measured in a short number of weeks for issues, just to give everybody enough time to make sure that we test the fix too. And then at this point, if we need to, we'll assign the CVE. My colleague Zach gave a talk with Corey Quinn earlier this week. He's repeating it today. Goes into much more detail about how that process is. But on the open source software side, we assign CVEs for issues that require customers to update their software, and we have a process for getting those CVEs. But even if you don't have that process, if you're just like a brand new open source project, you've never done this before, it's really easy to get CV numbers assigned. You just go to miter.org, and they have a whole process for that. And then the last, then the kind of last coordination step in this whole thing is that we start talking about disclosure, right, and how that's going to go. We'll ask the researchers, okay, do you have a publication deadline? Are you presenting this at a conference? Are you submitting it to a journal, and do they have a deadline for their next issue? Is there some firm date that's basically set in stone that we all have to hit? Or is there a bit more freedom there? And we'll ask what their disclosure preferences are, and express what ours are. Some researchers have their own disclosure processes, in addition to just publishing papers and so on. They like to make sure that issues are notified. For open source projects in particular, there are some special processes. So there's a special distros mailing alias and the OSS security mailing list that are both maintained on OpenWall. And those are really commonplace where open source security issues are disclosed, right? And if it's disclosed to OSS security, it's basically public, now, straight away. And if it's disclosed to distros, there's, I think it's about a 2-week timer that, the distros get 2 weeks notice of here's an issue, here's the fix. In 2 weeks time, make sure you've got your packages integrated and updated so that, people aren't unnecessarily impacted. And it's a pretty hard clock. There's no exceptions made. Once those 2 weeks are gone, that's it. It's public. But there are also, other embargo processes that are run where the researchers are well, we're going to hold this under embargo. It impacts multiple parties, maybe several vendors. We found a similar issue in lots of places. So we're going to have a 1 month or a 3-month embargo period. Here's the date. You better be fixed by then, you better be released by then, but also, if it's open source, please hold on to your fix. Don't publish it before that date, which is pretty important to make clear with them. Is that what you want us to do? Or are you okay with us, having this in some public branches beforehand? If they want us to keep it under strict embargo, at that point, we'll create a private fork of a repository, and that's where we'll start developing the fixes and patches. And that same set of core contributors will have access to it. And that is the part that's kind of in tension with open source principles. Because really at that point, if you're forced to go that route where it's under embargo, really only those core contributors will know about it. And you try to achieve a balance. You try to make sure you're good about making sure, good contributors make it into that core group, so they're part of that set of people. But, the average person just coming along, looking at your repositories, mailing lists, or source control, has no idea that that's going on, which, we've never found a better way. After all this, we test, we release a fix. We disclose the issue. We put it in our release notes. We put it in our change control, and we go over. And that's pretty much it. Like that's our process end to end. We run this a few times a year, typically for very low severity issues. We actually run our process fairly deliberately. Even if it's low severity, we actually kind of fake it and treat them like high severity issues, just because we want to be practiced and rehearsed if we ever did get a high severity issue, just to make sure that, you know, all the cogs are lubricated and we know how the machine works and we're able to do this. It's pretty cool. So when I'm looking at, you know, importing open source software, right? Trying to figure out, okay, I want to take in a new dependency, you know, okay, well, there's some things I got to do, right? And one is I got to make sure the licensing's okay and is compatible. And, you know, in my case, some lawyers do that, so I don't really need to worry about that. But the other part of it is I need to make sure it's secure. I need to make sure that, and it's going to stay secure, right? I don't want to import something just because it's easy and available, right? I need to make sure I can rely on it for the long term. And assessing this, there's a bit of an art to it. It takes judgment, but where I start, right? First place I start is, okay, I just look for the project's CV history, right? And I want to see like how many CVs have been like cut against this project, and how quickly were they handled in general. And like it's not a simple metric. It doesn't, like if a project has lots and lots of CVs against it, that doesn't mean it's a bad project or that they don't take security seriously. That can be quite the opposite. You know, sometimes the project's just extremely popular, right? And or it's just big. You know, Linux kernel has, I don't know how many CVs, but I'm sure it's in the hundreds. But that doesn't mean the Linux kernel folks don't take security incredibly seriously. I know they do. But literally try to sample those, take a look at them, read them. Like, do they just smell right? Like, does it feel like they, when they fixed that issue, that, you know, they had a really good report about it. They had a good understanding of what went on, and it looks like they had a good, robust fix to me. Or does it kind of seem like, you know, this feels like they're really doing the bare minimum, or that they hadn't got a lot of experience at doing this kind of thing, and it's it does take judgment, but just reading them, just sitting down for like an hour or two and going through all these CVEs, like I have definitely excluded projects on that basis, like just at that step. I'm like, whoa, that doesn't look right to me. Like, how did that ever happen? Or that fix also doesn't seem right. Or look, this just happened again 3 weeks later when somebody else found a related issue, you know? Stuff like that. And it's just enough to make you nervous, and you're kind of like, I'm not sure I want to use that. I'll look and see, do they actually have a security policy, right? We talked about why those are so important. If they don't have one, I'm like, wow, well, if I found a security issue in this, I wouldn't even know how to report it to them. That's a bad sign. So try to avoid those. I look at how will issues be disclosed, right? So if I'm going to pull in a library, right? Like personally, my ideal is that like I'll know about security issues, right? Which means like I should be a core contributor to that library. Like I'm a strong believer in that. And there's projects like that we consume where, you know, they're not Amazon or AWS projects, but like I'm in that set of people where I know about things. And sometimes it's because you're a core contributor and you're just literally one of those people who helps write the project. Or another way to do it, and I've done this for some other open source projects, is like just bring a lot of value to the table. You know, we have some security sensitive open source projects that we work with that our customers depend on. And you know, whenever they have security issues or whenever they have security fixes, I'll help them with it in terms of testing, right? Because I have access to a huge volume of scale that they don't. And I have access to, you know, lots of expertise and folks who can talk about what different workloads and patterns look like and can really give them very good insight. You know, I work with a project where they had a security issue, and they sent us the patch, and we caught errors in the patch, and we sent them back. We're like, well, actually you missed these few things, and you need these more. And bringing that value to the table, like jumping in and effectively being part of the open source project, like it pays back dividends, because that meant if they, when they had future security issues, they send them to me again. Hey, take a look at this, please, right? Again, there's no free lunch with this stuff, but if you do it, it's worth its weight in gold, And so I like to do that for a bunch of the core projects that we use. There's open source libraries and open source applications that we use as part of AWS services, as part of how we build things. That's no secret. But in general, not just taking the code off some source repository and compiling it, in general, prefer to have an actual relationship with the developers, to know them, and to be able to help when these things happen. In some cases, some projects do have pre-notification as a thing. Some projects even sell this and use it as a way to help fund their project, where you can pay them usually a relatively small amount of money, and you're now in a set of people who will get like a small amount of pre-notification that an issue is coming. Typically, they don't give you the full details, but it can be interesting. It's good to know that. I like to do that if we have it. I'll also look at the actual code, right? The great thing about open source, like the great thing about it, for consuming all this stuff, is that I can actually see directly how many tests that they have, how well written is the code? Does it feel like an absolute mess, or is it really relatively easy and straightforward to use? I think that's critical. In my world, where we ship online services, like it's pretty easy to measure the reliability of a system. Like it's right there in terms of what was its availability during the year, right? Like because it's a running thing, and people have to keep it running, and they have to make sure that it's reliable and robust. And your best way to assess it is, well, did it stay up? Did they, or did they have a bunch of issues? But code that's just kind of, if you're just going to consume it as part of something you're building and so on, it's not like that. You don't have that track record right there at your fingertips, but you do have the code, right? So you can just go read it. And like if it doesn't look right, if it doesn't feel right, try to avoid it. I look at the language that the code's written in. We use projects in all sorts of different programming languages, and we import them in different programming languages. But we always want to make sure that, well, whatever it's written in, we need to have expertise in that, because at the end of the day, if there is a critical issue in an open source library or application that we're using, like ultimately, like our customers, will hold us accountable for it. It's our service or something like that would be impacted. So we need to be able to fix it if it came to it, And so there's no point importing something written in a language we don't have a strong understanding of or ability to maintain and so on. I'll also check just how does the code do under static analysis. We've got a bunch of static analysis suites. If you want to see how we do it ourselves, you can look at our S2N project. We've got lots of static analysis hooked up. But I run projects through things like Clang and Fortify, and just for quick gut checks, right? Like, how many findings does it show up? What are we talking about? Is it like a mountain of issues, or is it like a relatively small number? And that can be a nice, just simple metric to help things out. And there's still no avoiding the kind of cultural and technical stuff. I'll look at mailing lists, and I'll try to see like how healthy the conversation is. If there's any kind of signs of like strong toxicity in the community, I'm like, ooh, that's a bad sign. You want to make sure people are free to collaborate and express doubts and so on, and that there's a pretty positive environment. And I'll look for that core cultural value, right, that I mentioned at the beginning. And that all put together, right, gives me It's a bit fuzzy, it's a bit based on judgment, but the more you do it, the better you get at it. A sense of like, oh yeah, I've got a high confidence in this thing. This thing, I'm very comfortable with, or oof, that makes me a good deal nervous. Cool. That's everything I have. Hopefully some of that is useful, whether you're writing open source software or just using it. I shouldn't say just, or if you're using it. Thank you all for coming. If you've got questions for me, I'll be out there for a bit at the end. Otherwise, thanks again.